My name is Steve Easley and I'm a building science consultant. And basically my business is about helping builders build homes that are durable and long-lasting, cost-effective to build, energy efficient, and healthy and safe to live in. Today we're going to learn about QII, or Quality of Insulation Installation. And that includes air sealing and air barrier technologies, as well as how we install insulation correctly to make the home as energy efficient as possible. How insulation is installed is just as important as how much is installed. The reason for that is what makes an insulator work is its ability to trap air. So if the insulation is compressed or we have voids or cracks or gaps, it's not going to perform nearly as well. And so that's why we have QII, which is called Quality of Insulation Installation. And it can be a pretty big compliance credit. In fact, dollar for dollar, it's one of the biggest bangs for the buck. But it's important to understand how you achieve QII. And that really starts with just paying close attention to the common sense things that we might think about every day when we're building homes that often is overlooked. And QII applies to both floors, walls, and ceilings. So let's just take an example of a typical home and really what we're looking for in order to achieve that level of quality of installation that we really need. First of all, the insulation needs to be fully lofted and fully fill the space. So for example, there's some language in some of the codes that refer to an insulation shall be installed in a way that's in full alignment with all of its air barriers. Well, what does that really mean? Well, it just simply means that the insulation is in contact, full contact on all 6 sides of its surfaces. What does that mean? That means that the insulation fully fills the cavity. In other words, it's in contact with the sheathing on the exterior of the building. It's in full contact with each sides of the studs here, of the framing. Also, that it's in full contact with the drywall in front of it. It completely fills the cavity. Now, why? Well, if this insulation becomes compressed and air can flow through here, that scavenges away heat. That's heat transfer by convection, and it substantially reduces the performance of the insulation. And so having this insulation fully lofted, fully filling the cavity, really improves its performance. Most fibrous insulation in general is very porous. So as you see in this picture here, we've got a lot of black marks on the insulation. That's not really mold or anything other than dirt, and that's because there's an air leak. If you look carefully at this photograph, you can see that the airflow is where all the leaks are at. So part of this whole QII checklist is making sure that we stop that air infiltration at these various locations. And that is specific to each individual part of the checklist, which is ceilings, walls, and floors. Part of a good insulation job really starts with a good framing job, because that means the insulation contractors don't have to constantly cut all these batts of insulation, and if they don't get the batts cut exactly right, then we get situations like this here where we get it's compressed and the batt is really a little bit too wide for the opening, so then that compresses the insulation and it doesn't work so well. So getting the framing right is really, really important. So having a good structural engineer that can help you use advanced framing techniques can also go a long way to helping reduce the energy loss in homes and increase the home's energy performance. Now, it's not uncommon at all to have framing defects where we have framing that just works out in such a way that maybe there's not a complete space that's the full thickness of a batt. Normally for 16-inch on-center framing, this would be a 14.5-inch space. But if the framing's a little off, guess what? The insulation contractor's got to come back and he's got to custom cut every one of these batts. So one of the critical components to a good insulation job is making sure that the framers are cognizant about getting their framing on center. And of course, if you can use advanced framing techniques where we try to eliminate some of that framing, that can also create more space for insulation. So QII requires that we have a continuous air barrier around the entire perimeter. That means floors, walls, and ceilings. And we do that to make sure that we don't get airflow through fibrous insulation. Now, when we talk about the air sealing components of this, there's some really important things to remember. It's not just whether you put the foam there, it's how good of a job you do making sure that you seal the penetrations. So for example, when we look at typical floors, oftentimes we forget about the penetrations that happen underneath plates. So for example, if you look over here, you can see that we have a foam sealant, it could be caulk, that seals where this plate interacts with the plate floor, because there's a lot of insulation underneath this slab floor. Also, you can see that we've sealed between the OSB and the plate. So these are 2 big leakage points, and when you add up all the linear feet of cracks and gaps in a typical home, it can easily be a half a mile or more. Also, what we want to make sure of is that we seal where the OSB meets at the top plate. So you'll notice up here we have a bead of sealant on the exterior where that exterior sheathing meets that top framing. So what we're trying to do is make sure that we seal all the exterior framing. That also means in the corners. So for example, if you look over here, you can see where we have electrical wiring that is penetrating to an exterior corner stud. Oftentimes those are forgotten, and that's a pathway for air to flow. Also, you'll notice around the outlet here, this is completely sealed. All this is part of our complete air barrier system. That's both at the top and the bottom. Another thing that's critical to the understanding how we can make these buildings better is by using what we call insulated headers. Normally, when we have a 2x4 wall, that 2x4 wall is 3.5 inches thick. And if we're using traditional framing material, that means that we might have two 2x10s or two 2x12s that would be about 3 inches wide. It's common practice to shim in between those places with a 1/2 inch of OSB or plywood. But if you were to put those two together, sandwich them together, and then go over that with a layer of insulation, that would be what we call an insulated header. And that means that you're going to add an roughly a R3 to the overall R value of the wall, which is going to substantially improve energy performance. Now, in this home here, we've just got solid wood framing, and the R value of that is a little bit more than roughly 3. And of course, that unfortunately is not as good as it could be if we had more insulation there. So when we talk about insulated headers, that's really trying to accomplish the heat loss where these big blocks of wood are at. QII has very specific checklists, and one of those checklists is for attics and ceilings. And when you look at the amount of penetrations that we have around attics, they can be pretty significant. One of the biggest areas of leakage is what we call, our can lights. And these can lights basically are not airtight, and even though they're kind of supposed to be. The reality is that how these can lights are installed has a big impact on how they perform. So the can light itself may be fairly airtight, but that doesn't mean that the area around it doesn't leak and creates opportunities for leaks. In fact, it's not uncommon at all to see can lights have over 9 cubic feet of air per minute leak through each can light. So if I've got 10 can lights in a house, that can be almost 1,000 cubic feet of air or 100 cubic feet of air per minute. A critical component to QII is proper air sealing around all the mechanical, electrical penetrations. So as you can see here, we have a gas pipe, we have a vent pipe. Those need to be foamed and sealed around. In addition to that, we have some electrical wiring and some plumbing penetrations. All those need to be sealed, but they also need to be diligently sealed. We want to make sure that you completely get an air seal around there and not miss any spots. Also, if you look at the top, you can see that there is a bead of sealant that runs between the exterior OSB and the top plate. And that is really an important area to seal because each of these spaces in between here can leak air. Now, if you look there on this one, for example, you can see that they ran a bead of sealant across, but they missed a spot. So it's important that people are extremely careful and make sure that they completely air seal. Because when you add up all these small cracks and gaps, that equals some pretty big leaks. Also now, if you look here at the bottom, you can see where the OSB sheathing intersects the outer plate here. We've air sealed here. That happens between each of these stud spaces. Also between the plate and the slab, it's really important to air seal because you get a lot of air infiltration underneath there as well through all the irregularities in the slab and the plate. Also, you notice here we've got these penetrations for plumbing that comes up out of the slab through the plate. Notice that's pretty well sealed as well. Obviously, we always seal around all the penetrations, but an area that oftentimes is overlooked is how do you insulate around plumbing pipes like this. So for example, this is an interior wall, and we see that we've got some plumbing pipes here. What they do is you cut the insulation in half. Rather than just compress the insulation and jam it behind the plumbing or the electrical, the ideal thing to do is to split the bat in two. That way you can insulate, and you've got insulation in front of the plumbing and in back of the plumbing. In this picture here, you can see where we have the insulations compressed behind the wiring. What you want to do is split that bat, put half the insulation in front of the wiring, the other half behind it. Here are some good examples about why you want to air seal and inspect before insulation is installed, because after the fact you'll miss most of this. For example, here where we have this air conditioning line set that penetrates through the wall, if you look carefully here you can see that is a pretty big hole. Likewise, you can see that they did a pretty good job of air sealing between the lower plate and the slab, but then if you look here where they air sealed between the building paper and the plate, they put the foam right over the top of the plate, which means there's no air seal there whatsoever. So the idea is to seal this gap between the exterior paper here and the plate or exterior sheathing. Another area that is often forgotten is where electrical wiring penetrations go through corner studs. So air would exfiltrate out through here, go through the exterior corner, and then we came back and we air sealed here, and also around the electrical boxes. Now this is an example of where garage floors to wall connections oftentimes aren't adequately sealed. Many times what happens, the garage floor is lower than the typical subfloor of the home, and so when they frame that means that subfloor comes up and butts up against that stud framing with no blocking in between the studs. And so that is a tough place to air seal. So blocking needs to be put in advance so that you could air seal to that blocking. So that's really critical that in QII you recognize that air sealing may require some additional framing steps. That's why air sealing has to take place before the insulation is installed. And if it's not, oftentimes they'll miss some of these critical locations that need to be air sealed because the insulation covers up all the gaps, and you don't know that until the house is drywalled and you do a test to find out that the house is very leaky. So we want to make sure that we put the appropriate blocking in. And this diagram here kind of shows all the different locations for air leaks around lower plates, subfloor, band joist areas. As you can see, they're all pretty leaky areas, and they all need to be air sealed according to QII. Now here's an example of using I-joists and how the type of framing materials you use can have an impact on air leakage. You wouldn't think that if I use an I-joist compared to, say, a standard dimensional framing lumber, there'd be much of a difference. But if you look here, you can see that these I-joists are pretty well insulated. But if you look at the thermographic image, you can see that there's a lot of airflow around it. Now I-joists are very common in construction, and they're very good materials to use, but you have to use a different form of air sealing. So typically what probably works the best in these applications is to use spray foam around the perimeter or completely fill the space with spray foam. Another area that QII addresses are cantilevers. This is a good example of a very poorly sealed cantilever. And if you look at the air gaps around where these I-joists extend out over that plate, you can see that there's several linear feet of cracks and gaps that aren't sealed. So a good solution for this would to simply use spray foam around all those perimeter openings and make sure the air seal that. Also, on the exterior of that wall, that cantilever space is critical that it's insulated, and that insulation needs to be in touch with the bottom of the subfloor. In the summertime, attic temperatures can easily get upwards of 130 to 150 degrees. And since most of our heating and cooling equipment and ductwork is located in the attic, that puts a lot of extra load on that equipment, makes it work harder, and drives up your cooling costs. Well, there's a cost-effective solution to reduce attic surface temperatures, or attic temperatures in general, and that's what we call radiant barriers. Now, what is a radiant barrier? Well, if you look up here, we have this shiny surface on the bottom of a roof deck. Basically, it's an aluminum foil material that's laminated to the bottom of the roof sheathing, in this case OSB. Now, the unique property of shiny surfaces is that they can reflect heat, but what you might not know, and why this works upside down, is that shiny surfaces can't give off their heat very well. So as the energy from the sun bakes down onto the roof deck, in a normal home, that gets absorbed and re-radiated in the attic, driving up attic temperatures. However, with this shiny surface on the bottom of the roof deck, that energy can't be re-radiated very well, so the attic ends up being about 30 degrees cooler, saving you a lot of money on your cooling costs. Another area we want to be careful of is where boots intersect with the framing. So for example, here we have a boot that's coming down through the attic ceiling, and you can see here they've done a good job of air sealing with some spray foam around that galvanized metal boot between that and the framing. So when the drywall goes up, this will be an airtight seal, and we won't get any leakage up into the attic. Now you might not think that sounds like much, but a study that Owens Corning did a few years back found that almost 7.7 CFM per duct actually leaks up into the attic. Here's an example of where our ductwork is in an attic is sealed. Notice the foam sealing around where the duct metal connections interface with the wood framing. And again, that can be a pretty big number. That's almost 8 cubic feet of air per duct opening. So if you have 10 or 15, supply ducts in a home, that can end up being a pretty good sized number. Here's another example of where they tried to do some foaming, but as you can see here, they missed about 25% of the area around this duct. Again, this would be a failure. So diligence in air sealing is really critical to get the desired result. Here's an example where they sort of did it right. They sealed completely around this ductwork, and so this creates a better air seal. Normally what happens is warm air is more buoyant than cold air, so it rises. So all of these ducts and pipes and penetrations that go from the conditioned to non-conditioned spaces creates a chimney that allows air to exfiltrate. Where fireplace flues exit the building, in other words, where these flues go from conditioned space to unconditioned space, are oftentimes very poorly sealed. So this is an example of a combustion appliance flue that is air sealed around the perimeter of it, but if you look closely where the actual B-vent flue goes through the metal shielding, there's no air seal there. So a better way to seal that would be with a fireproof caulk. So we still air seal around the perimeter, but where we have combustion appliance flues that might catch normal types of air sealing components on fire or cause a heat problem, you would want to use fire-rated caulk around those locations like you can see here. Another important requirement of QII is to make sure that we have a continuous air barrier between the conditioned space and the non-conditioned space. And that basically means that anywhere that we have exposed insulation, that has to be covered by an air barrier. A great example of that is a bathtub like we see here. You can see that the insulation below the drywall behind the tub is not covered with any type of air barrier. That requires some type of cardboard sheathing, or even drywall for that matter, any type of material that could be used as an air barrier so that the fibrous insulation is not exposed for air infiltration. You'll notice here that this bathtub area here has insulation behind it that's really well installed, but there's no air barrier material in front of it. So the air barrier material would have to be something like a OSB or drywall or some type of cardboard sheathing that would allow you to air seal to it. Give you an idea of what that might look like, this is a good solution, is where they're using roughly 1/8 of an inch thick cardboard exterior grade sheathing that would not qualify for shear support, but would allow you to put this over the insulation. You can caulk and air seal to the framing around it, and that's what's required behind bathtubs. Here's an example of the same material like that being required behind a tub. So if you look at the picture on the left with the pink insulation, they put this shower system in, but there's no air barrier covering the insulation. If you look at the picture on the right, we have an air barrier material there that covers the insulation, and that is correctly done. So again, we don't ever want to leave fibrous insulation exposed without some type of an air barrier material. All right, so here you can see this the image here of a typical attic, and you can see where the foam is insulated around the perimeter. And again, this is just to point out that every intersection between every framing member that separates conditioned from non-conditioned space has to be air sealed. Here's a great example. We have a stairwell where we have continuous studs that run from 8 foot down to the bottom of the floor. But where we have the stairway platform here, we have blocking here that can be sealed to. Oftentimes, if this blocking is not here, then we have a lot of opportunity for air infiltration. So it's important that we make sure that we have blocking and that we actually air seal around that blocking. This condition also happens knee walls, for example, in garages, as you can see here. Just simply putting a block between these trusses, in this case, creates an opportunity to be able to air seal it so that you don't have this air exfiltration. Another area that's important to pay close attention to is all these seams between plates, headers, and conditions where we have these gaps. Important that all these be air sealed. Like here's a great example of a stairway. You can see the photograph on the left. There's all kinds of gaps and cracks in those framing members. They don't look like much, but when you add up the thousands of linear feet of framing connections in a typical home, that adds up to be a pretty big number. So again, the concept behind QII and the air sealing side is just to make sure that we don't have all these gaps and cracks that allow air to move from conditioned to unconditioned spaces. And of course, many of the framing connections that are required in today's homes for life safety also can create issues. Part of QII wants you to have a slight little bit of insulation between those framing members and the drywall, and that's often done with a blue or a pink gasket like you see on the walls here. And again, the concept here is to prevent that air from exfiltrating up between the drywall and the framing members. This is a great picture of what a house looks like that's air sealed before attic insulation. As you can see, every penetration in this attic is sealed, in this case with spray foam. Wouldn't have to necessarily just be spray foam, but it could be caulks or fire retardant caulks, this type of thing. But again, every opening is air sealed, reducing that airflow from conditioned to unconditioned spaces. Another area that can present a great opportunity to reduce thermal defects is drop ceilings. Drop ceilings are basically more for aesthetic reasons, like tray ceilings in bedrooms, or for example here, this is an entrance to a bedroom where they've dropped the ceiling for aesthetic reasons, but that creates an interesting insulation and air sealing challenge. Here, for example, you notice that we have this OSB area that's framed on top of this drop ceiling. You'll notice that there's no OSB at the top of that. That's going to be difficult to air seal. They could insulate it, but the insulation might drop and settle down, and maybe you won't get the full amount of insulation that you might normally get. But mostly it's an air sealing issue. Kitchen soffits are considered to be drop ceilings that have a great opportunity for air leaks, as you can see here. And so oftentimes, like in this picture, you can see that the soffit is boxed down, or drop ceilings drop down, and so there's no real way to air seal that very effectively. So a common solution is to simply put the drywall up before that soffit's in place, like you can see in this picture here. Now, another area that's important in terms of understanding the thermal boundaries and QII requirements is exterior walls where we have porches and exterior overhangs that are framed between floors. So if you look at this image here and you can see that there's the red circle there, usually the area behind this, they don't put up an air barrier. And so what happens is, you can see from this diagram, air would be very easy to infiltrate in at that location. Essentially what QII requires is that there is no exposed insulation to unconditioned spaces, that there has to be some form of an air barrier. So if you look at this next image here, you can see where the big red arrow's at. They framed this house, there's no air barrier there, and so the walls will be insulated, but there's no air barrier over the insulation. Well, if you have fibrous insulation, that ends up being a pretty big air leak that the insulation is exposed to, and so the insulation is not going to perform nearly as well. Here's an example of an incorrect air barrier framing location. You'll see here that in this garage that they've added some additional framing, and the fiberglass insulation, the pink insulation behind it, there's no air barrier over that. What should have been done, some type of an air barrier material should have been put over that fiberglass insulation before the framing was installed. So one of the key components to QII is making sure that you put these air barriers in their appropriate locations before the framing is done, because it becomes much more expensive after the fact to come back in and try to put an air barrier over all that fiberglass insulation. Also, oftentimes in garages, they use what they call attic trusses, and these are one complete truss, and you'll notice here between these studs there's no exterior framing or blocking between the studs. So when you put the drywall over this, it's going to be really easy for air to infiltrate at that location without any blocking between the studs at the subfloor of that wall. Now, the correct solution to that is shown here in this picture. If you look at the lower left here, you can see that there's blocking between every one of these stud members, and so that means that you could, when you put your drywall up, you could actually caulk between that framing and the floor, or even caulk before the drywall goes up, so that you have an air seal at this troublesome location. There are 4 compliance forms for QII, which stands for Quality of Insulation Installation, and they are the air sealing guide for at the framing stage, the air sealing guide for ceilings and roof decks, the air sealing guides for framing for SIPs and ICFs, insulated concrete forms, and finally the QII Insulation Installation Guide. Now, there's a lot more information available in addition to these compliance forms on the wisewarehouse.org website.